In this video, we're going to solve radical equations. So let's take a look at first example. We have two radical, x plus 2 equals 8. So what you want to do is, you want to divide both sides by 2. So you get radical x plus 2 equals 4. Now how do you get rid of the radical? You have to square both sides. So you get x plus 2 equals 16. Subtract 2, you get x equals 14. Now, whenever you solve radical equations, you want to double check if that's the correct solution. So let's plug in 14. 14 plus 2 is 16. Radical 16 is 4. 4 times 2 is 8. So that is indeed our solution. Now you have cube root of 2x minus 5 minus 2 equals 3. So what you want to do is you first want to get rid of negative 2. You want to have radical by itself. So cube root of 2x minus 5 equals 5. And how do you get rid of cube root? You have to raise it to the third power, both sides. So you get 2x minus 5 equals 125. So you get 2x, add 5 to both sides, 130. You divide 2 by both sides, you get 65. So let's double check. 65 times 2 is 130. 130 minus 5 is 125. Cube root of 125 is 5. 5 minus 2 is 3. So that is the solution. Let's take a look at this example here. Now you got a radical, 2x plus 7 equals x minus 4. So if you want to get rid of the radical, you have to square both sides. So what happened is you get 2x plus 7 on the left. Because radical and square cancels out. And what about quantity x minus 4 squared? Well, if you recall, that's the same thing as quantity x minus 4 times quantity x minus 4. So you have to distribute or FOIL. You end up getting x squared minus 8x plus 16. Now this is a quadratic equation, so you want to probably make one side equal to 0, put everything else on the other side. So you get x squared minus 10x plus 9. Now let's see if we could factor this. Solve by factoring. So we end up getting x equals 9 or x equals 1. It looks like we have two solutions, but then again we have to double check. So let's plug in 9. You get 9 times 2 is 18. 18 plus 7 is 25. Radical 25 is 5. And what's 9 minus 4? That's 5. So 5 is equal to 5. So x equals 9 works. What about 1? 2 times 1 is 2. 2 plus 7 is 9. Radical 9 is 3. But what about 1 minus 4? That's negative 3. So 3 is not equal to negative 3. So x equals 1 is not a solution. So we call this extraneous. Extraneous solution is when you solve the problem, it appears to be a solution, but when you check your answer, it fails to be a solution. So be careful with extraneous solution. Let's take a look at this example. We got radical x plus 6 plus 1 equals radical 7 minus x. We have radicals on both sides. So what we need to do is we need to square both sides. So here what you got to do, you got to write it twice. Because you need to FOIL this. And on the right side, the radical disappears, so you get 7 minus x. So when you FOIL it, you end up getting x plus 6, because radical x plus 6 times radical x plus 6 is x plus 6. And when you multiply these two, you get radical x plus 6, and these two, you get positive radical x plus 6, and then plus 1. So you end up getting, you add up the like term, you get x plus 7 plus 2 radical x plus 6 equals 7 minus x. And what we're going to do is we're going to put the radical on one side and everything else on the other side. So you end up getting 2 radical x plus 6 equals negative 2x, and then 7 cancels out. 7 cancels out. Okay? So I'm going to divide both sides by 2. You could do that because this is an equation. And I'm going to get rid of radicals, so I'm going to square both sides. So you get x plus 6 equals x squared. Again, this is a quadratic equation, so I'm going to put 0 equals x squared minus x minus 6. So 0 equals x minus 3, x plus 2. So you end up getting x equals 3, or x equals negative 2. Now, we're not done yet because we have to check our answer, because we might have extraneous solution. Plug in 3, radical 9 is 3, 3 plus 1 is 4. 7 minus 3 is 4, radical 4 is 2. So it looks like 3 is not our solution. What about negative 2? That's radical 4. 2 plus 1 is 3. 7 plus 2, radical 9 is 3, so negative 2 works. So this is the only solution. So beware of extraneous solution. Let's take a look at this example. Now instead of radical, you got a rational exponent. So let's add 2 to both sides. You got quantity 3x over 4 equals 27. Now, how do you get rid of 3 over 4th power? Well, you need to raise it to the reciprocal. So what's the reciprocal of 3 over 4? That's 4 over 3. So now that cancels out. You just get 3x. What about over here? What's 27 to the 4 over 3 power? Well, you know that 27 is 3 to the 3rd. And you have 4 over 3. When you have an exponent next to each other, you multiply. So 3 cancels out. You get 3 to the 4, which is 81. 3 times 3 times 3 times 3. So you get 3x equals 81. So you divide both sides by 3, you get x equals 27. Now you could double check. Plug in 27 to 3, and then raise it to 3, 4, you'll get, minus subtract 2, you'll get 25. Let's take a look at our last example. You got quantity x plus 30 to the 1/2 equals x. I want to get rid of 1/2. So I need to raise it to the power of the reciprocal of 1 over 2, which is 2. Both sides. So you get x plus 30 equals x squared. This is a quadratic equation. I'm going to say this is 0, x squared minus x minus 30. Factor it. So you get x equals 6 or x equals negative 5. Now, let's double check. 6 plus 30 is 36. 36 to the 1/2 is 6. And is 6 equal to 6? Yes. That's a solution. What about negative 5? Negative 5 plus 30 is 25. 25 to the 1/2 is 5. And 5 is not equal to negative 5. So this is not a solution. This is an extraneous solution.